Hey, welcome to EV-Medics. My name is Christian and this is part 2 of a video I'm creating about a HVIL issue I'm having with a 2015 Tesla Model S, all related to the BMS that is mounted in the back of the battery. And what makes this case really outstanding is I tried two different BMS off eBay, used ones of course, and when I first mounted them into the battery, the software would properly recognize the HVIL circuit as functioning. I could disconnect it anywhere in the car, the alert would come up, I plug it back in, it would go away, so it would work just the way it should. And as soon as I ran the required software update, the alerts would come back and would not disappear again. So somehow, I have no idea to this point what caused this, but I found a solution which you can see at the end of the video if you want to skip through all the details. I was able to build a simple solution for that does not even require to drop the battery. Just to summarize, I checked the entire HVIL circuit based on this Tesla service manual, which is quite detailed. Went through everything. I checked all connectors, I checked all the resistors. So we have in a single motor unit, we have 4 of them. The dual motor has another one in the front, so 5, but in our case it's just 4. And I checked the total resistance, it's 240 ohms, checks out. All the connectors are good, no loose contacts, nothing. And what it boils down to is that the minimum current they're describing here in this document is not sufficient. So they're writing here it should be 20 milliamps nominal. And there's another document floating around online, or it's in Toolbox actually, where they say it should be smaller than 19, which is not accurate, because that would mean anything below 19 is okay, which is not. So actually this much older document is what you should use troubleshooting that. So if you have a car that cannot reach at least 18.8 milliamps, you should watch this video. Hey guys, welcome back. We received the BMS. That should go into our P90 Model S here with the HVIL issue. And I'm ready to put it into the battery pack. I already got the lid open here in the back. And yeah, stay tuned. So this is how the battery looks open, and the BMS actually appears to be exactly the same part number, which is a very good thing. Because maybe it goes through without a software update, which can be a pain on these old MCU1 Tegra cars. So stay tuned. Gonna unplug everything here. It should be a easy peasy deal. This battery is so much easier to work on than the first generation with the flat top here. It was a pain to get the BMS out, but this one seems really easy. So I got this done, take it from there. Okay, new BMS is in. It took me just a couple of minutes, super easy. And now I'm getting ready to hook this up and try it out. So on this side of the battery there's nothing really to worry about in terms of high voltage. The high voltage part is clearly marked in orange over here. And of course we don't want to touch anything coming from that side. There's one cable, I think this one here, has the full voltage on it, but it's fully insulated, just like a home outlet. So working on this side of the battery is not really a risk, but you gotta stay focused. Okay, I built myself these extension cords that allow me to run a battery on the ground next to the vehicle. And they basically just plug in. Like this. The same on the high voltage side. Go to the battery, do the same thing. Now comes the big moment. Okay, got the vehicle hooked up. The BMS has power. There's a little LED blinking here. Okay, just booted the car up one more time. See what's going on here. So BMS version mismatch still, even though the part number is the same. Contactor fault is gone, but we still have HVIL. Still didn't clear. Amazing. So until HVIL is gone, we can obviously not even reprogram, run a software update. Yeah. That's good. Now the battery is open and we can really check the complete circuit and rule out any faults. HVIL codes are gone, to my surprise. And all I did is I was messing with this contact here in the high voltage connector. Even though it looked fine from the outside and it provided good voltage during the tests, it seems, well, that's the only the only lead I have at the moment, because as soon as I did that, the HVIL fault went away. So all this is a tiny little switch. As soon as I plug this high voltage connector out, the HVIL code should come back. Yeah, so it just rebooted and the HVIL code is still gone. I will now swap back to the old BMS because we have a version mismatch, and then let the car sit on the logger, see how long it lasts. But this was kind of obvious that that's the problem. All right, the old BMS is back in the car. If our HVIL circuit is still closed and operational, the contactors should fire up and we should be able to hear a nice click when I'm reconnecting the 12-volt power supply to the car, which I'm gonna do now. With the old BMS, the HVIL code is back. That is amazing. Unbelievable. Let me check the log. Okay, got the replacement BMS in again. If this is now still not showing any HVIL errors, I'm gonna leave it connected overnight and check again tomorrow morning. This is a really interesting problem. I was wondering where this one is. And because I don't want to run a software update without being sure the BMS is the problem. So it could have been two things: this intermittent contact here and the BMS being shot, which is quite unusual but not impossible. So let me put this back together and then we fire this baby up and see if the HVIL code is still gone. Okay, we got the new BMS back in, the one that did not have a HVIL error before, so I didn't touch anything besides these connectors. And I booted the car back up, and sure enough, I don't get it. Here it is again. Before it was gone with that BMS, and basically the same hardware setup, everything else untouched. Interesting problem. We'll see. Okay guys, it's a day later. I swapped the BMS, the old one that was in the battery and the new one, back and forth. And I learned a lot of things how that HVIL system works in the car. So currently I'm running the BMS that I bought on eBay, and I was able to reprogram it, ran the software update. It at first looked really good. All HVIL codes were gone. I could plug the HVIL circuit in and out, and alerts would pop up and go away again, so it looked really promising. And then there was one alert left, which was the pyro fuse. The previous battery that BMS was in, the pyro fuse was expired, so it had this pyro fuse stored as expired. So I went through Toolbox, updated the pyro fuse date, expected the car to fire up, and sure enough, the HVIL code came back. So right here, like before, right here it is, yeah. So now we are back at the drawing board, and I'm trying several things now. First of all, I did that yesterday, but I'm gonna walk you through that again. I activated the HVIL circuit through Toolbox to be able to measure the current that is flowing through it, because there's a requirement. It should be in a certain range according to some documentation I found. So I wanted to measure the current, but if the car is not firing up, the HVIL circuit is not power supplied. Normally in Toolbox there's a way to activate that, and I show you how to do this real quick. So we have the option here for BMS HVIL current source on. I go for 6,000 seconds. That is what? How long is this? I don't know. So I go for 6,000 seconds to have ample time, and then we click run, and with that the current source is switched on, and I can see it's happening because I'm reading voltages now on my logger here. Right. So with that in place, I'm able to measure the current while the circuit is constantly powered up, and get some amp readings, which normally I can't, because as long as there's a volt, it's only sending short signals like I showed you before on the graphs. All right, let's try that. Stay tuned. So got my beautiful snap-on tester, $1,400 device. Big piece of junk if you ask me. Waste of money. I got it set to milliamps, and we are back to the footwell here, and my disconnect, the cable here is disconnected, going back to the battery, this one, into the BMS. So right now I have a closed loop. I mean, I bypassed my disconnect, and I'm just gonna hook up the amp meter in between here. So once I disconnect this, you will hear the car complaining. Did. All right. We go into the amp meter, and with the yellow lead back into here. So we're reading 17, 18 milliamps currently. So according to the specs, 18.8 is minimum. So I have no idea if that is really relevant or not, but I gotta rule it out. So in order to rule this out, I want to measure the current on a known good car. And that brings me back to the P90 I have here. And hopefully we learn something doing that. I also want to rule out that there's an issue with the power supply to the BMS. So I have a jumper pack connected, and currently it's reading 12.3 volts. This appears to be the power supply for the HVIL circuit, and usually if the car is operating, the voltage is closer to 14 volts. So I just want to see, maybe the BMS got weak and therefore is unable to push enough amperage into the system. So I connected a additional lab power supply, one side connected to ground and the other one here on the connector, and I'm gonna push another 5 amps into that, which raises the voltage to 13.2. Here I can show you. I switch it off, 12.3 on, 13.25. So now let's see if the amperage increased. 17.9899, not much. Not much at all. Okay, off again. 12.34. Yeah, 5 millivolts or so. That's nothing. It's not a big difference. So I guess we can pretty much back to 12 point something volts, 17.94. So that is not a big difference, and I think we can pretty much rule out this is caused by the power supply or a weak connection or anything. So now I'm gonna measure my known good car and see what that produces. Back to the P90 and our connector here. So I'm gonna put the amp meter into this circuit. I will disconnect this connector and put the amp meter in between, basically, and that is only the HVIL loop. Usually the car has a charger here. This one doesn't have a slave charger, so this is basically just a bypass. That connector is supposed to go into that charger, and this loop just closes the HVIL circuit. Okay guys, look at that. I got my amp meter looped in 19.35 milliamps, which is quite conclusive. So that's a healthy 90 kilowatt hour battery, the same BMS, putting out 19.35 milliamps. So I think we can call that used BMS shot. There's no other conclusion I can take on this. I don't know what else to say. So I guess we gotta send it back and ask for another one. It is a couple of days later, early in the morning, still dark outside. I received the second BMS, installed it, and just booted up the car. We still have the amp meter in series here in the circuit with the 60 ohm resistor. Right here. And we're showing a BMS mismatch and no HVIL. So now we're at the same point we were with the first eBay BMS. So if I disconnect the HVIL here, let's see if it comes up. No, it doesn't. So what I want to do is, before I'm going to run the software update, I'm going to trigger the BMS to deliver the voltages into the system through Toolbox, and I want to see if we can reach the required 20 milliamps here before I run the software update, because when I did the BMS swap last time, I missed the step. Okay, a little bit better, but still below specs. So most likely even that BMS is faulty. I don't know what else it could be. So I just put the other BMS, the first one we bought on eBay, back in here because it's already programmed to the car. And I want to try one last thing. I want to provide 6 volt power to this cable here, the one coming out of the BMS and going through all the HVIL loop to the front and back into the BMS. And what I want to find out is at what point the BMS measures the current. If it measures the current back here where there's just a ground symbol, so it would basically mean that there's just a resistor going against ground, that test will definitely fail. But if we are measuring the current back here where the cable comes back in, that could potentially solve our problem. So if this is really just a power source here at the beginning going through the car, the yellow black cable, then we could potentially fix the problem if the computer doesn't notice it. And yeah, if it's measuring here at the source, then of course it's not gonna help at all. So for that reason, I plugged in my power supply into our black yellow black cable here, 6 volts, and the circuit is reading as it should. 18.8, so that should pass. 18.9, perfect. So now we're going to fire up the car and we see what happens. The BMS is toast anyway, and there's nothing to risk. So we're not going over the maximum voltage, which is around 9 according to the documentation I could find. So yeah, I don't see any problems trying this. Okay, moment of truth. Moment of truth. I'm getting in here, hooking up the battery and listening for the contactor. Oh, this is so... Oh no, it clicked. It clicked. Can't believe it. The screen is still down. We are reading 18.9 here. So that's all healthy. But I heard it clicking. You have to wait for the screen to come back. Only the typical windshield, whatever, windshield not clear. The ventilation in the bumper. Everything else is gone. The car should start. Let's try it. Here's the key. Oh no, man, it starts. It's in gear. This is cool. I would say that is really cool. Okay guys, the car has been running for 2 hours now, and it looks like we are really in business. Okay guys, the car has been running for 2 hours now, and I'm quite positive that we are in business because no codes popped up, no alerts popped up. The contactors close when I open the door. It accepts a charge, so no further issues found. And I talked to the customer, and he's open to have like a Russian hack applied to his car because he's so happy that it's basically working again. That we might add just a buck converter below the seat and drive the car with that solution. But in order to make sure this is a long-term solution, I'm gonna let the car idle and potentially for 1 week, and I'm gonna monitor it if it stays stable and pops up no strange alerts. But at this point, I think the BMS can really not tell where the current is coming from, and it doesn't care actually. All it does is measuring what comes back to the BMS, and that's a stable current. So now I'm gonna lock the car just to go through a shutdown. Now I plan to just lock the car and go to a shutdown loop. I want to wait until the contactors close and the BMS goes to sleep to see if that triggers any problems with this power supply being on all the time. And yeah, you can hear the AC running because the door is open. So far so good. The complex programmable logic device detects a condition where it cannot go to sleep, but is told to do so. And it cannot do that because the high voltage interlock loop is on. And we all know why that's the case, and I gotta figure out a way how to do that. So I'm thinking about developing a small circuit that communicates with the BMS and only switches on when necessary, and also with the right current load. So this is how the circuit looks like. It communicates basically, or it monitors the voltage and the current going into the HVIL circuit and induces just the right amount of juice to make the BMS happy. And most important of all, the whole HVIL circuit is still functioning as it should. If anything is disconnected, it's gonna shut the battery down. So right now you can see it's activated, the LED is on, and it's maintaining 19.4 milliamps, which is right in the sweet spot. If this is too high or too low, the circuit will shut down, and the unit basically maintains this. So if I connect my HVIL in here, you can hear it's shutting down. We have 0 milliamps, and now when I connect it back to the circuit, the BMS should ping. Maybe I have to open the door. No. Okay, so now the BMS is disconnected off the vehicle. Once I plug it back in, it will ping the circuit. It does it by itself, but it takes a while. So click, and now the LED is on, and we are back to 19 point something milliamps. So all good. So yeah, obviously I cannot install that in the customer car, so I came up with a compressed version of it in a nice enclosed housing that I'm gonna install under the back seat. So that is how the part looks like. Nicely enclosed with a 1 amp fuse in a circuit, and all it takes is this is going to battery plus. Gonna attach it to the same circuit we have here in the back. It's fused with 5 amps. That's the BMS fuse in the front of the car. And then another 1 amp fuse in here, double safety. This will go to ground, and that's basically, that's coming from the BMS, and that is going to the rest of the HVIL circuit through the vehicle. And yeah, that's gonna be under the back seat. Easy accessible. And we also have a LED in here that shows the status, just like right here. Yeah. So again, this is only necessary if a BMS is not producing the required 18.8 milliamps. 18.8 is at the lower end. If you have a car with that symptom, it's for sure going to cause issues. So if you have a vehicle that has the correct total circuit ohms and voltages, but is still acting up, measure the current. And if this is below 18.8, or let's say below 19, consider this. So now it's time to wrap up this battery and put it back in the car and install this device. Okay, got the housing all closed up with Seeker Flex, of course. What I'm doing now, before I install this thing, is check the connector on the bottom to have enough preload to engage with the pins in here. So these have 0.8 millimeters thickness, and I have a wire here with exactly that dimension, 0.76, yeah, around 0.8, and I'm gonna use this to check the pretension in the connectors. Okay, below the car now. So I'm starting with this row here. I know that the second pin from the left is not populated, so there will be no drag. And the upper row, it's the last one not populated, and the third one. Okay, let's start here. This should be not populated, it's not. Nice and tight. Nice and tight. That one is not populated, correct. Nice and tight, nice and tight. This one is not populated. Good, good. So you can see the wires staying in here. That's what we want to see. Not populated. Populated. Now the white one. Nice, 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 nice. That one is not populated. Bottom row. Okay, good, 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 and good. So I'm about ready to install the battery, and you might have noticed it's parked on a special fixture that I built, not only to move batteries but also to precisely lower and lift them up, and I'm going to show you later how that works. I use this because in cases like that, diagnostic work that often takes a long time, I don't want to occupy a lift, and yeah, while it's quite important to have the ability to connect the battery to the car and for continuous work, and that would require to move the car in and out and in and out all the time. So with this setup I can leave it on a concrete slab and just manipulate the battery however I like it. So, but for now we're just gonna push it in and line it up with the vehicle. Just like that. Now we're gonna pull it upwards a little bit and take it from there. Okay, battery is lined up with the car. And okay, the battery is now hanging below the car on these studs. Here we go. Now, oh yeah, now it's good. Ah, super smooth. So that's the point where the connectors start engaging.
Oh, right there.
Yeah, and then I usually go over the rear end and wiggle on it.
Yeah.
Okay, wiggling is done. Last inch or so. Boom, we're in. Now the front. Okay, the car is finally running. And I have the unit installed here. Everything is working as intended. I put a simple splice, or whatever you want to call it, into the main HVIL that goes into the battery and to the BMS. That's this cable here, this pin one. So in case we have to troubleshoot this and we don't know if there's an issue in the long run, we can simply plug this out and put the original harness back. This LED will turn off when the car goes to sleep, just like the experimental board I showed you before. So yeah, that looks promising. So far so good. I wish I had a better way to fasten this, so the next version I'm gonna add a tab here in the back, so maybe I can bolt it here to that point and with longer wires. But for now this will do. Now I'm gonna take the thing on a test drive. Missing in my PMW, I don't know. That's for the parking sensors. That's for the Shutter in the bumper, and washer fluid low. Nothing concerning. Looking good. Let's roll. So I'm gonna take this thing for a spin now. I mean, this has been the classic beached whale sitting in my bay for like 3 weeks, tracing this problem, and it was really a hard nut to crack. And that's the reason why 3 other repair shops, 2 dealerships, and a repair shop couldn't figure this out. They just gave up, I guess. So I learned a lot, and I developed this part, which maybe comes handy for somebody else in case there's another weird 90 out there with this symptom. I feel this might be a 90 specific problem, 90 kilowatt hour battery problem. So yeah, in case you're interested in that solution, reach out to me.